that suggested that a body would not change its state of motion unless an external force acted on it. He realized that the elliptic...
Yeah, this is very common, no? Any body, any object will not change its motion unless some external forces acted upon it. How many times your mom had scolded you that you have not picked up a cloth and that has been lying around there in the same chair for 3 to 4 days, and after 4th day your mom came to your room and she picked up your cloth? Did that happen with you? Happened with me many times, right? अगर आप किसी चीज को उठाते नहीं हो, वो अपने आप नहीं उठती है, right? So there's some external force that have to be acted on the particular object. Why people are leaving and joining again and again? There's 4 people left and joined back. Okay, like whoever joined back, if you can hear me, put a reason in the chat box. Why are you getting out of the room? Yashit joined twice. Yeah, so sorry guys. Let's keep on seeing the video.
The motion of the planets around the sun would be possible if instead of a tangential push, there was a central pull. For example, in the case of a stone that is being flung around with a string, the tension is always toward the center and not in the direction of velocity. Similarly, he deduced that the planets were moving this way because the sun was constantly pulling them. The most important realization came when he saw the moon's center and not in the direction of velocity. Similarly, he deduced that the planets were moving this way because the sun was constantly pulling them. The most important realization came when he saw the moons of Jupiter behave just like the planets. That is, they were going around Jupiter just like the planets went around the sun. He also saw the Earth's moon went around the Earth in a similar fashion. He figured this could be true only if the Earth attracted the moon and Jupiter attracted its moons, just like how the sun attracted the planets. And of course, finally, he understood that the reason an apple fell toward the Earth was because of this same force of attraction. And thus was born the idea that every point mass attracts every other point mass in the universe.
Yeah, so could you guys make connection with the centripetal force and how Kepler observed moons? Like hamara moon is revolving around Earth, right? Jupiter's moons are revolving around Jupiter, that he could see with the naked eyes, and he derived some equation. Yeah, then what Newton did is he saw centripetal motion, and he saw that just as Earth is attracting its moon towards itself, sun is attracting Earth towards itself. So that some force, some kind of a centripetal force is acting on Earth by sun, and it is attracting it towards the sun. Okay, and that's how we came up with such a universal concept of gravitation. Okay, we'll go through it once again at the end of the lecture.
Now, using Tycho Brahe's observations, Kepler came up with or deduced a few results, which are generally called Kepler's laws. The first law was that he saw that all the planets moved around the sun in elliptical orbits, right, in such a way that the sun was at one of the foci of those orbits. So the top view of the solar system would look like this. So the second law is that the planet, one of the foci of those orbits.
Yeah, guys, this is the first law of Kepler's. Kepler's first law says that all the planets move in an elliptical motion, and sun is at one of the focus. Say, sun is at the center, and all planets move in an elliptical direction. Okay, know that Kepler's ने बताया कि how planets move around the sun. Okay, so he said sun is at the focus and all planets move in elliptical direction, and that is the first Kepler's law. Any questions on it? First Kepler's law. Sun is at the focus all planets move in elliptical direction. Pretty easy. Yeah. You can't see the screen. Acha, you are not able to see the screen. That's why you are reconnecting. Okay, guys, you still have problem? Okay, should I share the screen again? Can you guys see now? Okay, Sakshi, you are not seeing. Okay, you are not having that problem. Jatin is saying no. Okay, whoever cannot like is not able to see, I feel sorry, but like let's see its recording. Okay, let's see its recording iske baad and try to rejoin the meeting. Okay.
So the top view of the solar system would look like this. So the second law is that the planets move faster when they're close to the sun and are slower when they move further away from the sun. Now, the same law is sometimes restated in a different manner. It is said that the aerial velocities of the planets is always constant. Now, what does that mean exactly? For that, let's just take the example of a planet that's moving in an elliptical orbit like this, and let's say this is the sun over here. Now, let's take the case where the planet is close to the sun. Okay. Now, what is the area swept by this planet in, let's say, one day? Now, in 1 day, let's say the planet moves from here to here. So the area swept will be this, right? So the area of this region is the area swept by the planet. Now, what the law says is that when, let's say, the planet comes to the other side, the area swept by the planet in the same time interval will be exactly the same. So for that to be true, the distance traversed by the planet has to be lesser, right? So that these two areas are exactly the same. So this implies that the distance traversed by the planet when it's close to the sun is greater, and the distance traversed by the planet when it's further away from the sun is lesser in the same time interval. Or in other words, the speed of the planet is greater when it's close to the sun and it's lesser when it's further away from the sun.
Yeah, guys, how much can you understand this? Like, to explain this, you always know that, right? 21st June is the biggest day in our in India, or in the year, right? 21st June is the biggest day. And you also know that November, right? No, 21st December is the shortest day, right? Shortest day in our calendar, right? So when the sun is away from the earth, like let's say there's an earth and it is very away, yeah, so the time chota ho jata hai. And when we are near the sun, time bada ho jata hai, right? Summers mein days are larger, winters mein days are shorter. Okay, yeah. So that's one more analogy. Or the Kepler second law states that speed of planet towards the sun is greater than speed of planet away from the sun. यहाँ कम होता है, like यहाँ कम है, यहाँ ज़्यादा है speed. Why? Because sun की gravity है, right? Sun is a massive object, बहुत बड़ा object है, right? Imagine that sun की gravity is lot more than earth की gravity. So what happens is when earth gets near sun, yeah, यहाँ उसे gravity ज़्यादा होती है, right? Because it is more, it takes the speed of time is it takes like less time to travel from here rather than from here. Okay, and this is the second law. Yeah, in your syllabus you are just supposed to write about it. Okay, but you can always remember the biggest day and smallest day. It is the easy thing to remember. Yeah, you are waiting for that day when the night is longest. कि ज़्यादा सोने को मिलेगा. Yeah, ठीक है. Yeah, so this is the second law. Okay, how gravity of sun affects the planet. Yeah.
Or in other words, the speed of the planet is greater when it's close to the sun and it's lesser when it's further away from the sun. So the third law says that the square of the time period of any two planets is always proportional to the cube of their semi-major axis. Now, if that sounds confusing, let me just explain. Now, if I take a planet that's going around in an orbit like this, the time period is obviously the time taken to complete one full revolution. Let's call it t. Now, what is the semi-major axis? For that, just consider the largest diameter. There is this, and half that length is what we call the semi-major axis. Now, let's call it r. Now, what Kepler found was that t square is always proportional to r cube for any pair of planets. It is greater when it's closer. The cube of their semi-major axis. Going around in
Yeah, so guys, third law, it's thoda sa more important. Why? Because it helped Newton to come up with its own gravitational law. Okay, so what third law says that time is proportional to the distance. Okay, time is proportional to the distance, and in a way that square of time, what do we understand by that? एक पूरे revolution को, एक पूरे lap को कितना time लगता है, उसका square is directly proportional to the radius of ellipse, cube of the radius of ellipse. This is the radius of ellipse. Yeah, I know that it is very messy, extreme math is coming over here, but just know that कि अगर रेडियस ज्यादा है तो टाइम ज्यादा लगेगा. Of course, right? Pluto will take more time to revolve around sun than Earth would take. Yeah, Mercury का एक साल छोटा होता है than Earth के एक साल से. What is Earth का साल? What is how longer is our year? 365 days. Perfect, right? Thank you. Yeah, 365 days. So if we go away from sun, away from sun, जितना जाते हैं, there's a Pluto, there's Jupiter, Venus, उनके साल बड़े हैं हमसे. Okay, so that is what third law is, that t square is proportional to r cube. जितना ज्यादा distance होगा उतना ज्यादा time लगेगा to revolve around sun. Okay, is like how much do you have like third law clear in your head? Because third law is thoda sa more important. Okay, I ask how much and you give me confidence scale. That's why I love this class. Okay. Yeah, so if question comes to you in exam, state Kepler's law, write Kepler's law, you need to remember these laws. Yeah, you need to remember these laws as they are. Yeah, and in the third law, you have to write t square is proportional to r cube. So what does that mean? T square upon r cube equal to constant. Yeah. Okay. 3.535. ठीक है. Yeah. So just remember that the जितना ज़्यादा दूर है sun से a particular planet, the more time it will take. जितना sun से पास है उतना less time it will take. Okay, and don't worry about squares and cubes right now because you do not have it in your syllabus. Okay, just know that t is proportional to r. Yeah. Okay, now you are going to, when we say t square is proportional to r cube, it is t square upon r cube equal to constant. Now write this thing in your notebook right now. Write this thing in your notebook and show me a done in the chat box. Sumika, I can see you, so Sumika is like, shit, kaise camera on ho gaya? Yeah, but I could see you writing in the notebook, which made me happy. So thank you for doing that. Okay, done. Yeah, t square upon r cube equal to constant. And that is Kepler's third law. Yeah. Okay, so what about Kepler? What are the questions that will come in your exam? Can anyone come off mute and tell me?
State Kepler's law.
State Kepler's law. What are you supposed to do in that?
Revise Remember the Kepler's one, write that.
Kepler's 3 laws, remember and write as they are. Yeah. Any laws, any definitions you have to write as it is without changing a word. Okay. So if you want to write language in your book, you can do that. Or if you want to write in here, you can also do this. Like this is also valid language. Okay. You can refer from your book or from here. Yeah. Okay. And I hope that like you are like thoda to there's understanding of Kepler's 3 laws. Okay. Now you are not going to write blankly about it. Yeah. And the third law is important. T square is directly proportional to R cube. Okay. Now hold on to these learnings, and from these learnings we are going to derive one super important equation. Okay. Yeah. So how much ready you are to do that, or are you feeling tired? You are not able to see the screen. Yeah. You are ready to do it? 4. Okay. Ready? Yeah. Do think. To think. Commit, think. Quickly, guys. Eyes को बड़ा करो थोड़ा सा. Do think.
Commit.
Think, commit. Do. Yeah, very good. Think, do. थोड़ा उल्टा बोल दिया तो commit. ठीक है. Yeah, very good job, guys. Thank you for being so alert, so on point. Okay, now I'm going to need like a lot of your help in this, because this is something that we want our good attention to. Okay, all eyes on the screen. Yeah. So coming back to our wheel, we understood that force is in direction toward center and velocity is tangential to the circle. And this is nothing but what this force is called?
Centripetal.
Thank you so much, right? Centripetal force. Yeah. I kept my video off so that you could see my screen. You guys still have problem of not seeing the screen?
No.
No, okay, okay, thank you. Yeah, so we will understand it one by one. Okay, Suraj, can you read it?
Okay. First, centripetal force acting on the stone is F is equals to ma. Force is mass into acceleration.
Yeah, remember the Newton's second law? Force is mass into acceleration. Yeah, force is always directly proportional to mass. या कितना बड़ा ऑब्जेक्ट है या उसके हिसाब से आपको फोर्स लगाना होता है, करेक्ट? एंड फोर्स इज डायरेक्टली प्रोपोर्शनल टू एक्सीलरेशन. दैट मीन्स दैट F equal to ma. Yeah. So now we are going to write centripetal force. Okay, centripetal force. F equal to ma should be clear in your head. Okay, force is proportional to mass, force is proportional to acceleration. So centripetal force is equal to mass of stone, let's say mass of stone, multiplied by centripetal acceleration. Okay, centripetal acceleration. This particular acceleration is different at different points, and there's a whole lot of big derivation is there for coming up with centripetal acceleration. Okay. Adi, can you read the second point?
Know that velocity is constantly changing for stone. So it is the centripetal acceleration. Therefore, A is equal to V square upon R.
Sorry. A equal to V square upon R. Yes. Yeah. So A equal to V square upon R is nothing but centripetal acceleration. Okay. Centripetal acceleration ka formula is not in your syllabus. Like how centripetal acceleration equal to V square upon R is not in your syllabus. if you want to understand कि कैसे आया centripetal acceleration equal to v square upon r, there's video, ping me personally, I'll tell you. Okay, it's a big derivation जो आपको 11th standard में है, not now. Okay, हाँ, go ahead Radha.
Didi, do we need to do this derivation for exams as well?
Yeah, this derivation you need to do. Inverse square law of gravitation, जो भी derivation I'm telling you now, वो है आपको. But AC equal to v square upon r is not in your syllabus. Acceleration equal to v square upon r is not required. You just need to remember it. Okay. So if acceleration equal to v square upon r and force equal to ma, then can you put a into the equation in our main equation? Yes. And what is the value that you are getting? Anyone come off mute quickly, tell me.
F is equal to m into v square upon r.
Perfect, right? Very easy, no? Like if you want, you can, like for now, I have called this equation 1. So you can call this equation 1. This is 2 and you can write, put 2, a की value हमने इस equation में substitute कर दी. So we got the equation F equal to mv square upon r. Okay. And I have called this equation 1 over here, but you can put equation 3 here. Okay. Let's put equation 3 here. Write this in your notebook right now. Take like quick 2 minutes to do that. Tell me done once you are done. Till now, very easy. F equal to ma, a equal to v square upon r. Therefore, F equal to mv square upon r. Not difficult till now. It gets thoda tricky. Jaake. Till here, any questions? Done. Okay, done. No. Yeah. Are you guys done writing? Radha, tell me.
Didi, I have a question in second one. A is equal to v square upon r. तो वो किससे आया?
Yeah, I told you, no, there's a centripetal acceleration ka formula. It is based on a theory that when object moves in a circular motion, its velocity is constantly changing. So if you can say over here, there's a lot of vectors, like you do not have vectors in your syllabus. Yeah, so velocity ka jo vector hai, wo badalta jata hai. Yeah, and from that theory, ये formula आया है, v square upon r. And it is not in your syllabus. 11th को अच्छे से उसका derivation है. Not now. Yeah. So it is based on a theory कि velocity is constantly changing and the radius is constant. And somehow this formula is derived. If you want, I'll share you the video. I tried to understand it. 15 minute deke, but yeah, I got it. So if you want, I can tell it to you, but not now. Okay, it will confuse other students. For now, just remember a equal to v square upon r. Okay, I got like 5 done. Like our rest of you guys are writing because this is important. Are you done? Yeah, okay, I'm not getting many thumbs up. Okay, I trust you that you are writing. Yeah. So guys, what is the formula of velocity? I sort of showed you that, but what is the formula of velocity? What is velocity? Anyone? What is velocity? Speed, v equal to gt. What is g? Achha, you are raising hand. Go ahead, Sujan.
Velocity का formula दीदी distance travel upon time taken.
Yeah, distance traveled upon time taken. Radha, you want to say something else?
नहीं दीदी.
Yeah, nahi, right? Yeah, but आप ये ठीक है फॉर्मूला वगैरह छोड़ो. Like you say that now. अभी तो आप छोटे हो, but मेरा भाई recently has learned how to drive car. Yeah, तो बोलता है 100 किलोमीटर 1 घंटे में मैं जाके आया. Yeah, so what was its speed? 100 किलोमीटर 1 घंटे में. So 100 kilometer per hour. Yeah, he can travel by the speed of 100 kilometer per hour. Itna जोर से गाड़ी चलाई. Okay, this was example. This is not true. Okay, but he has learned to drive a car, and he like keeps on boasting कि I drive car in such a speed. Yeah, by saying that कि अरे 50 किलोमीटर तो मैंने आधे घंटे में कर लिया. Yeah, so that is what your speed is. Okay, you also will say this once you learn how to drive bikes, how to drive cars. You will also say things like it. Okay, it is always distance upon time. Yeah, okay. So velocity is distance upon time. Yeah, so what are we going to do? We are going to make our equation a little bit more complex, and we are going to put things for velocity. Yeah, so for velocity, if you look over here, अच्छा आपको आती है बाइक खतरनाक. Yeah, so velocity, if you look over here, is a distance upon time. If a stone is moving in a circular fashion, yeah, so what is the distance that the stone is traveling? It is equal to circumference. Perfect. Yeah, and what is the formula of circumference?
Pi r 2 pi r है शायद.
2 pi r. Yeah, it is 2 pi r. Yeah, don't worry. Geometry की revision हमें चाहिए. Yeah, but you are correct. Yeah, 2 pi r. It's the circumference. The distance is 2 pi r. And how much time we need to travel this एक पूरा circle? Time t. Okay, we don't know how much time, so we are assuming it at some constant t. Okay, so t is the time we require to travel from one distance and coming back to that particular distance again. Time is t, distance is circumference, which is equal to 2 pi r. Is it clear? V ka formula is clear. Yeah, now find out what is v square, and you are going to put this v ka formula in the third equation that you had got. mv square upon r. Yeah, substitute it. V ke jagah substitute 2 pi r upon t. So f equal to mv square upon r. Can you do that? Can you substitute v square? Achha, in here there's some change. mv square upon r. So what is the square? Like, can anyone come off mute and read the sort of ugly formula that is there in your book right now? Or let's say a beautiful formula. Ha, Prathamesh, read it. Ha. Tell me.
F is equal to m multiplied by 2 pi r by r the whole square by r.
No. Like square it, no. 2 pi r upon t का square क्या होगा?
2 pi r upon t का.
हाँ,
2
square.
pi r upon t square.
हाँ, what is its value? Prathamesh, you only try. 2 का square is?
2 का square is 4.
Yeah, 4. Pi का square is?
25. मतलब pi का. हाँ, pi का pi square.
Pi square, okay. What is r का square?
R square.
Perfect. So 4 pi square r square. T का square?
T square.
T square. Perfect. Yeah, what we did? सबको square किया. Whatever is in bracket, we squared everything, right? And we got this beautiful looking equation, and it is a sarcasm, that 4 pi square r square upon t square multiplied with m divided with r. Yeah, so divided with r matlab multiplied by 1 upon r. Yeah, dividing it by something is multiplying it with 1 upon something. Yeah, so let's remove this part, and we have come up with this equation that m multiplied with 4 pi square r square upon t square multiplied with 1 upon r. Guys, this is r. I'm sorry if it is not looking as r. Okay, this is r. Yeah, so now simplify it. Can we cut something? r दिख रहा है किसी को?
Yes. Yes.
Yes, can you read the equation? कैसे कट करूं मैं? हाँ, go ahead. Radha, anyone, go ahead. एक r
एक
कट हो
आर
जाएगा.
हट जाएगा.
Right, just एक
R
r
हट
कम हो जाएगा. Perfect. बाकी वैसे के वैसे रहेगा. So what is the equation that you got? M multiplied by 4 pi square r divided by t square. Yeah. So this is the equation that you got. Okay. Now, yeah, what was the, okay, let's hold on to this. So are like everyone in the classroom have come up with this equation? Do you have this equation ready with you? You can also rewrite it as 4m pi square r divided by t square. Yeah, it's okay if don't type it, guys. I know that the typing pi square is taxing. Don't type it. Huh, Radha, tell me, you have any doubt? Radha, you raised your hand? No?
एक्चुअली दीदी वहाँ पे जो पाई 4 पाई आर स्क्वायर है ना, so दीदी here we cut it from r and r, so दीदी फिर यहाँ पे yes I got it दीदी.
2 r थे और नीचे एक r था, राइट? सो ऊपर का एक r कम हो गया, राइट? r square is nothing but r multiplied by r. Yeah, got it? Yeah, okay. Now we know that कि Newton learned something from Kepler. Yeah, Kepler का जो third law था, what was Kepler's third law? T square upon r cube equal to constant. It was Kepler's law. Okay, let's write it here. Kepler के law में, because Newton learned from Kepler. So T square upon r cube equal to constant. Yeah, constant. So what we are going to do is we are going to multiply and divide whatever our beautiful equation is by r square. Okay, we are going to multiply and divide this beautiful equation by r square. And how are we going to do it? By simply multiplying and dividing it with r square. What will happen when we do this is, okay, r square. R multiplied by R would be R cube. Okay, just look into the screen right now. 4 pi square. R multiplied by R square is R cube. And in the denominator, we would have T square multiplied by R square. Okay. Now, can you pick out some components from here and match it with here? T square, are these two numbers available also here and here? Yeah, is it available? T square upon r cube equal to constant, and I can see T square and r cube in this equation as also. Okay, so what he did is he put T square upon r cube as k. K is a constant. Okay, कुछ भी constant होता है उसको k बोल देते हैं, right? So what is the reverse of this? R cube upon T square equal to r cube upon T square equal to
1 by k.
Perfect, 1 by k. Okay, r cube upon T square equal to 1 by k. Yeah, perfect. Now we are going to substitute r cube upon T square by 1 by k. Okay, so whatever we are remaining with is m multiplied by 4 pi square k. Okay, no, not k, 1 by k. So k will go here and r square. Yeah, is it clear? How did we arrive here? Damn, it rhymed. That is it clear to you that we used Kepler's law and we substituted 1 upon k for r cube upon t square. So we came up with this equation 4m pi square equal to kr square. Is it correct? Everyone tell me. Everyone looking at me, staying with me. Yeah, finding it difficult, not difficult, I'm not sure, but once you do it on your own, you will be able to understand it. Okay, so what we did, like, can quickly anyone come off mute and recap from velocity? What did we do? Like, since we found out velocity, what did we do? Adi, can you try?
Didi, when we find 2 pi r upon t is the velocity,
Yeah.
we put in the f is equal to ma, and a is the acceleration which is equal to v. So we put f is equal to m into 2 pi r upon t.
Okay, okay. Just one point. Centripetal acceleration is out of our syllabus, and that is equal to, like, a f equal to ma. Perfect. Adi, you are perfect. F equal to m multiplied by acceleration. The acceleration was
v square upon r.
perfect, right? And what is v?
V is 2 pi r upon t. So
Yeah.
if we separate, we
2 pi r कहाँ से आया? 2 pi r
is the circumference of the circle or the whole distance traveled by the object.
Yeah. And what is t? Capital T is time period. Time period to complete one revolution. Yeah. Yeah. So we put everything into f equal to ma ka equation, and we cut r. And after that, after cutting r, we need to introduce something. What did we do then? In blue fonts that is there.
We introduce the Kepler's third law, which is t square upon r cube is equal to constant.
Yeah. And how did we do that? By multiplying and dividing equation with
R cube, r square.
r square. Yeah, we multiplied equation and multiplied and divide equation that is written in blue with r square. Yeah, and we found out t square upon r cube equal to k. Therefore r cube upon t square equal to 1 upon k. So, like, our sort of final beautiful equation, it is not final, guys. Yeah, there's some trick in it. Okay, but till now we are here. Okay, our equation reads 4m pi square equal to, sorry, 4m pi square divided by kr square. Give me a done once you are done writing it till this point. Okay, done. Yeah, it's okay, guys, if it's training your muscles. It's like, aise hi our brain grows. Okay, not that difficult. If we make sense of every step, r square divided by r square क्यों किया? Because we want to introduce Kepler's law. Kepler's law के according there's a constant. That's why. And multiplying and dividing thing is actually nothing, right? We are not disturbing this equation. When we multiply and divide it with same thing, we are not disturbing the equation. Yeah. But Kepler's law के according we could fit it into a constant. ठीक है, सिर्फ r square क्यों लिया? बच्चे, because there's r over here, no? हमें r cube बनाना था. Yeah, look at Kepler's law. Kepler's law में r cube है, right? And there's single r we could see over here. To make it r cube, हमने r square लिया. Okay. Yeah, and if it is straining, if it is, if you are finding it difficult, very good. Okay, pay extra attention to it. Practice it 3 more times when the lecture is over. Okay, that's how our brain grows. Okay, that's how we grow. Okay, so it's okay if it is sounding difficult to you. Okay, it is difficult, but we are going to do it. Yeah, so we are here and all of you are done, right? So tell me if the mass, you know that pi is a constant. Okay, who was that? Guys, you know that pi is a constant. Pi is a constant. Is it clear? Yeah. Can you
Yes.
provide async sheet? Async sheet kya hota hai? Are we? Yeah, we are trying to understand inverse square law of Newton, inverse square law of gravitation of Newton through Kepler's law. Okay, so now look over here. 4 is a constant, right? It is a number. Okay, it will not change. What exactly is constant? Constant is something that will not change. Okay, so 4 is a constant. Yeah, so when we are talking about a particular object, its mass is constant, right? Its mass is not going to change. Okay, mass is also constant. Pi is also constant. It is a definite value. It is not going to change. K is a value. K is a constant. We learned from the Kepler's law that t square upon r cube is constant. So K is also constant. But what is r? R is radius. Yeah. And when we consider different shapes like elliptical shapes, right? In circle, radius is constant, but when we consider elliptical shapes of planetary motions, we know that distance kam zyada ho jata hai, right? When we are near the sun, distance kam hota hai, and when we are away from sun, radius is more. Yeah, elliptical mein radius is not constant. Yeah, so from this, we understood that centripetal force or force is inversely proportional to square of radius. And this is the inverse square law of gravitation. Yeah, F is, हम सारा F के लिए निकाल रहे थे, okay? Left side पे F था. So F is equal to 1 upon r square. That means that F is inversely proportional to the square of radius. And this is the inverse square law of gravitation. Yeah, write this, absorb this for a minute. Yeah, you have a question. Go ahead, Radha.
Yes, Didi, can you please repeat the heading for this derivation?
Inverse square law of gravitation. Inverse square law of gravitation. Okay. Yeah. So you know that, right? F is inversely proportional to radius square. And what is this F, guys? What is this F we are talking about? What is this force?
Force.
Yeah, exam mein aata hai. This derivation exam mein aata hai. What is force? But what kind of force are we talking about?
Centripetal force.
Okay, and when we think about planet, what kind of force we are talking about?
Gravitational.
Gravitational
This
force.
is nothing but a gravitational force. Okay, I'm going to remove my beautiful drawings. Okay, that this force is nothing but a gravitational force. So Kepler showed us कि कैसे move होते हैं planets, and Newton answered why and through which forces planets move around the sun. Okay, so we learned that there's a centripetal force acting on Earth through which Earth is moving in orbit around the sun. Okay, there's a centripetal force acting on Earth. That's why it is moving around sun. Okay, let's say this is the sun and this is the Earth. Okay, I'm so sorry for my drawing. Yeah, now you know that what is the what is the bichara planet which is no more a planet right now?
Pluto.
Yeah, Pluto, yeah, and it is farthest away from sun. Yeah, Pluto is सबसे ज़्यादा दूर है. Yeah, so gravity on Earth is 9.8. Yeah, gravity on Earth is 9.8. What is the gravity of Pluto? Gravity of Pluto is 0.62. इतनी ज़्यादा कम है. Yeah, so what we learned that force is inversely proportional to distance or radius. जितना ज़्यादा दूर planet है उतना कम force होगा. Yeah, the more the radius, the lesser would be the force. Make sense, guys? Yeah, so let's find out Mercury. Yeah, even I'm trying to find out now gravity on Mercury. Okay, no, Mercury is 3.7. Okay, there must be some other factors there. Yeah, so for now, let's just understand that force is inversely proportional to radius. Yeah. So the conclusion is Kepler ने बताया laws, लेकिन उसका reason ठीक से explain नहीं किया. नहीं, Kepler ने बताया how planets move around the sun. उसने सही से बताया कि जितना planet दूर है उतना ज़्यादा time लगेगा, जितना planet पास है उतना वो fast से cover कर लेगा. सही बताया. But वो इस orbit में क्यों रहता है उसका reason उसने क्या दिया कि some kind of angelic force is holding planet. Yeah, he could not explain it with science. Newton explained it with math, with science. No angels, no God. There's a centripetal force acting on planet, which is inversely proportional to square of radius. Yeah. So we actually learned inverse square law of gravitation before we learned universal law of gravitation. Tomorrow we are going to learn universal law of gravitation. Okay. Quite a heavy lecture for both of us. So yeah, tell me, Prithavesh, what is doubt that you have?
Didi, Pluto is the farthest from the sun, so uski gravity